So this is the famous penguin, the difference between ECB and CBC modes. So let me get rid of my Windows machine. I don't need that anymore. All I need is a terminal. Let me get rid of stuff that doesn't matter here, like that and that. All right, here's my terminal. All right, and so let's CD and then CD 141. All right, let's, I probably already got it here actually. It's going to be one-time pad. All right, so, all right. Oh, that's the one-time pad. Pardon me, that's not what I'm doing. I'm doing electronic codebook mode. ECB is what it should be. I'll just make a directory. Oh, I don't need a directory. I'm going to use Python in interactive mode. Okay. Python. Yeah, that's right. Yeah, but CBC is not what we're doing. So I'm just using Python 3 here. All right, this will do. All right, so now I'm going to encrypt this thing various times. I'm just going to do it using Python in immediate mode here. So I run Python 3. Now I need to have this image, so I'm going to save it somewhere. Save image as. And I'm going to put it in my home folder and then in the 141 directory. There we are. So I'll have this thing called tux, and it's going to be .bmp. That's a bitmap. It's an uncompressed bitmap. So if I show in Finder, it's here. If you double click it, the image opens in an image viewer here. So that's tux. And because it's an unencrypted bitmap, we can look at this in a hex viewer. I wonder if I can right click and open with. Let's go to hex. All applications. Hex fiend, okay. If we look at it, you can see it has a header up here, which is stuff like the height and width of the image and details, and then it has the blocks, and so this is like gray, and this is gray again, and this is gray again, and this is gray again. It just has many, many bytes that are all identical, encoding the same color. If you go down someplace, the color is going to change eventually. There, this is some other color. There's like only 2 or 3 colors, and this is white, 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 white. So that's all. There's many, many repetitive bytes here in this image because it just encodes each pixel separately. So we're going to encrypt this thing in Python. So to do that, we just do this. Okay. So I import AES from CryptoCipher. I use a key. I'm just going to use anything for the key. I just use this, so I just it to be 16 bytes long. Now I create a new AES object with that key and in mode ECB, electronic codebook mode. So I've created a cipher object. Now I'm going to read the tux bitmap into a variable named clear. That'll read the file, tux bitmap, and create clear, which is going to have it. Now, I could encrypt the data in clear this way using my cipher object I created and encrypt it, but I'm not going to be allowed to do it because it's not exactly a multiple of 16 bytes long. So I have the issue of padding or how I'm going to fill up the blocks. But there's another issue from what I just showed you. I really don't want to encrypt the first 48 bytes anyway. I want to leave them alone because I want to encrypt the visible part of the image, but keep the header intact so I can open the image and see what it looks like. So I want to encrypt only part of the data. The part of the data, now I can find out what's going on with the length here. The length of it is this thing, 943794, and if I take that modulus 16, it's 2 bytes left over. So I have an integral multiple of 16 and an extra 2 bytes. So what I'm going to do is I'm only going to encrypt this portion of it. I'm going to skip the first 64 bytes for the header and the last 2 bytes. That's going to be what I want to encrypt. That's going to, now the length of clear trimmed is going to fit in 16 byte blocks now. Now, so this I can encrypt, then I can stick back in the first 64 and the last 2, and I'll create a file I can open, and almost all the pixels will be encrypted. That's the plan. So, let me just make this window skinnier so it's easier to jump back and forth. Okay, So now this will encrypt the data in clear trimmed and put it in ciphertext. And now I just need to rebuild the ciphertext. So I'm going to take the first 64 bytes of clear and put in the ciphertext, and then the last 2 bytes of clear. That will make ciphertext that includes the entire image. And then I'm going to write that out as tuxecb.bitmap. So that gives me the original header, the encrypted pixels, except for the last 2 bytes I'm going to leave alone, and then I write this file tuxecb bitmap. That's it. And now that's here, tuxecb, and there you see what we saw before. That's what it looks like when you encrypt it in electronic codebook mode. You can still see the penguin. All the blocks of solid color are just turned into different blocks of solid color. So that's the problem. Now we're going to do it with CBC and see the difference. So for CBC, we're going to read the ECB into a variable named clear. All right, we're viewing the end of the file. That's the time. Now, here we are. Now to encrypt it in the CBC, we've already got it here. We're going to switch to electronic codebook. So I'm going to need an IV. So I need a 16-byte IV. I just used that. And now I create a new AES object with mode CVC. And when you use cipher block chaining, you have to include IV. So now I've got that object. And now I just do the same encryption again. Ciphertext is cipher encrypt clear trimmed. It still remembers the clear trimmed from before. So that's encrypted in the other mode. And now I just rebuild the ciphertext and write it out to a file again. So this will create the first 64 bytes of the original, the ciphertext here, and the last 2 bytes, and write it into tuxecb. And that one is this one. And as you can see, that's the one that just completely scrambles it into random colors so it hides the penguin. That's why cipher block chaining is better than electronic codebook. It hides the large-scale patterns as well as the small-scale details. And that's really it. There's some stuff you do here to get the flags. But that's the famous penguin demonstration. This is why nobody should be using electronic codebook, because it leaks out large-scale data. And cipher block chaining is better. It prevents this problem, but it introduces another problem of padding oracles, and we'll look at that in a future class in more detail, but you've already seen a summary of how it works in the lecture. So let me stop this recording.